So I'm going to attempt to integrate 1 plus sine x squared. Now, I don't know what to do with this. I would probably just expand the bracket. So 1 plus sine x squared means that you have 1 plus sine x times 1 plus sine x. So that's what it looks like. And I guess the only thing we can now do is to multiply the 1 times the 1, then the 1 times the sine x times 1, sine x times sine x. So we now get 1 plus sine x plus sine x plus sine squared x dx. And we can combine these like terms. That gives us 2 sine x. So that now gives me 1 plus 2 sine x plus sine squared x dx. Now, I know how to integrate the 1. I know how to integrate sine x. But how do we integrate sine squared? It's not that straightforward. We're going to need at least one identity. I think we're going to need 2. So generally, the identity you would use would be a double angle formula. Whenever you have a sine or cosine squared. So the identity I'm going to start with is cosine 2x. So cosine 2x is cosine squared x minus sine squared x. So this sine squared looks like this sine squared, so that's good news. We need to get rid of this cosine squared and rewrite it in terms of sine squared. So cosine squared is simply 1 minus sine squared, using the other well-known identity. So now we know that cosine 2x can be written like that. And again, we can combine these like terms. So cosine 2x equals 1 minus 2 sine squared x. Now, again, I'm looking for sine squared, so I'm going to rewrite this as 2 sine squared x equals 1 minus cosine 2x. So I brought this to the left side, and I've brought that to the right side. Now I'll just divide by 2. So that's going to give me sine squared x equals half minus half cosine 2x. And that's the identity I need. So this is what I'm going to use to replace my sine squared. So this identity is not given in the exam. You need to either remember it or derive it. So I'm now going to replace my sine squared with that. So my integration now looks like this. 1 plus 2 sine x plus half minus half cosine 2x dx. And one more thing before I integrate, I'm going to combine like terms. So I get integral of 3 over 2 plus 2 sine x minus 1 half cosine 2x dx. So one final reminder that the integral of cosine ax is sine ax, but then you divide by the constant. Whenever you have a multiplier, use the reverse chain rule and you divide by that multiplier. But the ax here is unchanged. All right, so that's really important. And we're going to use this to integrate that. So we know the integration of 3/2, we know the integration of sine, and now we know the integration of cosine, so I can write my final answer. It's 3/2 times x. The integration of sine, just as a reminder, the integration of sine x is negative cosine x. So I'll write minus 2 cosine x minus 1/2 times sine 2x divided by 2. So that's this 2 there, plus c. And finally, before you give your final answer, you multiply these two because they're both in the denominator. So your final answer would be 3/2x minus 2 cosine x minus 1/4 sine 2x plus c. That there would be your final answer. That's how to integrate whenever you see an expression that involves a sine squared. But in this case, in our question, we had to expand the brackets before we even got to that stage. We needed to use an identity that you can either remember or derive in the exam. And even these integrals, they're not given in the exam. You're expected to know these. So it's quite a lot of work to get to this final answer.